Hi guys, it's been a while, but here we are. Tomorrow we have a test and you guys need to make sure that you guys are understanding what trig ratios are. We told you guys that you guys should have Sakatoa on all your papers because that's going to be your best friend. In case you don't remember how to spell Sakatoa, here it is one last time for your enjoyment. And this stands for sine, cosine, tangent. And how this helps you is because it helps you determine what pieces of information you have and what trig ratio you're going to end up using. So O stands for opposite, H for hypotenuse, and A for adjacent. And then we have hypotenuse again, opposite, and adjacent. Now, what do those letters mean? You guys should by this time should know. But we're talking about the position of the side in regards to the angle. So if we have theta here, it means that we're gonna look at that as our point of reference, and opposite goes directly across. This side is opposite, so we've been doing that pink. The other side is adjacent. Adjacent means that it's touching the angle. So this is adjacent. Okay, these all again are depending on the perspective. Hypotenuse does not. I went ahead and I highlighted that because hypotenuse is always going to be hypotenuse, always opposite of the 90-degree angle. Okay, so the ones that are going to change are the opposite and the adjacent. On this side, if we're looking at this angle as a reference angle, you guys should by now know that this is opposite, right? It's not touching it and it's furthest away. And the one touching it is the adjacent. Remember, one of our kids, Giselle, was like, oh, okay, you can think about it as theta and the 90-degree angle being best friends, and adjacent is going to be the one bringing them together. Okay, so thank you, Giselle, for coming up with that little idea for us. Now I'm going to go ahead and put this aside, but just either write Sakatoa on the top of your paper or have it somewhere handy so that you're able to use it during the video, okay? All right, so the very first thing that I'm going to go over, this is going to be really quick. Review over the review that it says IM2 Unit 7B review. We went over this in class. I don't know if everybody got a chance to write everything down, but we just wanted to make sure that everybody got a little bit of review on this. So the inverse function is used for, we had A, B, or C, finding the unit of a side, finding the degrees of an angle, or neither. And the winner chicken dinner was degrees of an angle. Remember, the inverse function is where we have that -1. It doesn't really stand for a -1. It's just basically saying it's doing the opposite of it. Okay, so it's not giving us a side, but it's giving us an angle. So inverse function, if you guys see that, remember that it's that -1. And in order to get that on your calculator, I don't have a calculator here at home, but you guys have to push the second button. So these are my pretend calculator buttons. Second, and depending on whatever trig function, you want to use tangent, cosine, or sine. You're just going to push that button because above these buttons on our handy dandy calculators, you have, it says tangent inverse, cosine inverse, sine inverse, okay? And the only way to access those is by pushing your second button, which on the school calculators is blue. And then the words up here are blue because it's the second function of that button, okay? All right, so I think you guys got that one. This one is the one where you guys were like, I have no idea what's going on. What am I gonna do? Now, this is easy. I think that you guys just saw the double triangles and then thought, oh, sorry guys, that this was hard, but it's not. If you take into consideration the fact that we already work with similarity, and meaning that the scale factor from here to here is going to be the same, mathematically it's not correct to say that this could be a 4 and a 5 because then that would make them congruent, not similar. But if you guys know or remember anything about similarity and scale factor, you guys are going to remember that that means that there's a number that either was multiplied by or divided by to get there. And basically when we reduce, we're going to get the same number. So it doesn't matter what this number here is. We'll do heart. And whatever this number is, let's do star. Okay, whatever these are, when we reduce this, it's always going to be the same as this because they share the scale factor. Okay, in class we use 2 and 2.5 as an example, but I'm going to leave numbers out of it this time, okay? Because we just want to know that this is going to be similar to the star, and the 5 is going to be similar to the heart in the terms of these triangles to each other, okay, in terms of their relationship. So if we're talking about cosine of B, of angle B, that's this angle here, and if you guys like still using your theta or your colors, I'm just going to go ahead and put that. So cosine means what? We have our handy dandy SOHCAHTOA. Cosine is adjacent over hypotenuse. So if I look at my triangle, my heart is my hypotenuse, and adjacent means that it's touching. Remember, from the theta to the 90. So this is adjacent. What they're asking me is which one on this side, which letter, and we know it's not going to be Z because we never work with the 90-degree angle, so it's between W and Y. If I were to have one of the sine, cosine, tangent ratios, which one would be a 4 over 5? Okay, which one would have a 4 over 5? Now, if we don't know, we want to work them each out, then we can. Okay, but it says sine of which one? I don't know if you guys want to do it, but automatically what should pop into your head? I'm going to do sine, cosine. Actually, I'm not even going to do that. I don't know where my head was going with it. It's going to be sine of each. So you can do one of two things. You can redraw. Here I have W, Z, Y. W, Z, Y. And then I can say this is my point of reference. Okay, sine would be SOH for my SOHCAHTOA. That means that it is opposite over hypotenuse. Opposite is here, and hypotenuse is here. So that would be star over heart. If I have on this side, I use Y as my reference angle. Then I have opposite here, star, and hypotenuse, heart. Okay, which one matches this? Obviously, it's W. That's our winner, winner, chicken dinner. So sine of W is basically the same as cosine of B. Okay, I hope you guys understand that. Let's go one more time on the bottom, and we can try work that out. Okay, so here we have, if it says sine of A is equal to cosine of what? Okay, so sine, here we go. A is my angle of reference. And we have sine, so that means opposite. And let's just keep the star over hypotenuse. And we have a heart. So we want to make sure that whatever we're doing on this side is going to match that. And if you want to write on this one, you can, or you can draw them separately here. But we need cosine. So let me draw my triangles. Again, not drawn to scale. They're not perfect. We're not Picasso. Okay, some of you guys did wonderful drawings on your quizzes, and some of you guys decided not to because you were like, I got this, I don't need that. All right, so let's see. If I'm using W, sorry if my hand is shaky because I don't know why the phone seems heavier for me today. I have cosine is adjacent, so that would be this side over hypotenuse. Okay, does it already look like I'm matching here? It doesn't really because I got the bottom and the hypotenuse. So let's see, on this side, if I use W and I'm using adjacent over hypotenuse, look at this. We got our star and our heart in the right places. Okay, so in this case, it would be cosine of Y is basically the same as sine of A. I hope you guys are understanding kind of like there's a little relationship there, right? But you know what? If you guys don't see it and you guys need to do this extra step, we're gonna provide you guys with scratch paper so that you guys can do your work. Okay? Let's go on to the next one. Hopefully that made a little bit more sense. Oh, let's move this. All right. Again, I apologize if you guys hear noise. All my kids are up. Tangent of V. So now we are actually looking for the angle measure. So I'm going to make sure that I'm going to put a little theta here so that I don't forget that I'm using my inverse functions, because some of you guys do really well in your labeling but then don't realize that you're not using your inverse function, and you guys get this randomly weird small number or huge number, right? Okay, so if I'm going to look for tangent of V, I'm going to be looking for my opposite and my adjacent. My opposite goes directly across, and my adjacent is touching it. Again, joining that theta and the 90 degree. Okay, so what is tangent? What order? I have a 50-50 chance of getting it correct. Is it 5 over 12 or 12 over 5? Well, let me see. Let me go back to my middle name that Ms. Ramos and Ms. Corrales gave me, right? Everybody here is Sakatoa, so we had like Nathan Sakatoa, we had Michelle Sakatoa, and some of you guys keep putting that on your papers, and that's great because it looks like you guys are understanding what you need to do. All right, so if I'm looking for tangent, I'm looking for opposite over hypotenuse, so that's my pink over my green. Tangent of theta is equal to 12 over 5. Now, whenever I see that, I remember I have both my numbers with my fraction. What do I have to do? I have to use my inverse. So I'm going to go ahead and copy that down. Tangent, inverse, and you're going to put in your parentheses 12 over 5 on your handy dandy calculator. I don't have a calculator, but I'm going to say that you guys do. And your answer should be 67.38, and we're going to round that to 67.4. So the measurement of angle V is equal to 67.4 degrees. Okay, and again, feel free to pause this video at any time so that you guys can get clarification, rewind it, maybe I didn't say something correctly, send me a remind. All right, so now, again, sine of angle W. We have all three sides, but we don't need all three. We are just being basically tested on whether or not we understand what we're looking for and the perspective we're looking from. So here we're looking from our W's, okay, from our W, no, sorry, not our W's. So I'm gonna go ahead and put my theta there as a symbol for myself, and sine should be like, okay, then I'm looking for my opposite over my hypotenuse. I should know that my hypotenuse is the longest side directly across from my 90 degree angle, and my opposite is opposite of my angle. So here's my angle all the way across. What's not working, mamas? Technical difficulties with an iPad. Oh, the battery died, mama. Tell Bethy to put it away, to charge it. Okay, so opposite over hypotenuse. 45 over 53. Okay, so that is my sine of W. And again, I'm going to go ahead and do sine inverse, 45 over 53. And that is 58.10. So my sine, so my measurement of angle W is equal to 58.1 degrees. All right. Okay, so most of you guys don't have this one on the bottom. I believe that we changed it last minute because it was more alike, something that you guys are gonna have or see on the test tomorrow. So here we just changed a couple of letters. Feel free to pause the video so that you can do that to yours. And we are looking for JK, which is this side right here. Okay, so we have this is our angle of reference. That is where ideally my theta is going. Okay, and then I have, or I'm looking for my adjacent, and I have my hypotenuse. So if you guys can see that automatically, you guys don't need to do this, but if you guys still need the color, like a couple of people have been telling us that they do, so now I know I have my green and my yellow, so I'm going to use cosine. Okay, so cosine of 51, because we do have the angle measure, is equal to adjacent over my hypotenuse. Now, from this point, sometimes you guys need to do the switcheroo, or you guys just need to multiply by doing opposite operations, right? So we're going to go ahead and multiply here because our variable is on top. We multiply by 8 on both sides, and that leaves us with 8 cosine 51 is equal to x. Now this is the point where we told you that the district might stop it and not even ask you for the actual angle measure, or I mean the side length, but it's going to ask you to identify which one was the correct last step. So you would select 8 cosine 51. Okay, and if you plug that into your handy dandy calculator, you get 5.03, which we round to 5. Okay, one more, guys. All right, so here again, it's the same thing. Cosine of W. Cosine of W. This is my angle of reference. And cosine, if I look back here, is adjacent over hypotenuse. That means the one that's touching it and the hypotenuse. So my hypotenuse is going to be identified first as opposite from my 90 degree. And my adjacent is touching it, uniting it with its best friend, the 90 degree angle. If we go ahead and plug that in, cosine of W is equal to 12 over 37. Okay, we can use our inverse, cosine inverse 12 over 37, and that equals 71.07 or 71.1. 71.1. Yeah, so then the measure of angle W is equal to 71.1, not 71.7, 71.1. Okay. All right, these last two, there's nothing really much to show you guys except that you guys see that either you're using your chart or you're using your calculator. When it's asking you for the measurement, you just need to basically ignore the X there, and you have to use your inverse symbol. Once you put in the inverse, cosine inverse, you're going to do 0.956 equals, and it's going to spit out a number that it's a degree. So you're going to say 17.1 degrees. Same thing down here. Sine inverse, right, because we don't know what the angle is, that's what we're looking for, is equal to 0.391. So sine inverse 0.391 is equal to 23 degrees. All right. Okay, thank you guys. I hope this helps, and I hope that you guys do well on the test tomorrow. Bye.